Let's talk about mass versus weight. So, what you've hopefully learned in a prior science class, maybe in middle school, was that mass and weight are different things. What we normally learn is that mass is the amount of stuff in an object, and mass is the amount of matter that an object is containing, or that is, it is created out of, or it's formed out of. Weight is not always a constant. Weight is a property that is influenced by the force or by the acceleration due to gravity. So mass in and of itself is just how much stuff do you have. Weight is what is the influence of gravity on that stuff. And if you change the amount of gravity by going to a different planet or a moon, then you have changed the amount of weight. And that's why, if people are talking about, what's your weight on Earth, and you're like, oh, I weigh 110 pounds. Then if you went to the moon, your weight would be much less. Your weight on the moon is actually about 1/6 that of Earth, okay? Because the moon is much less massive and there's less gravity here. And we'll talk about gravity later on in the year, exactly what makes it up, how mass deals with gravity. But mass is an intrinsic property of an object. It is the amount of matter that is making up that object. The weight is the gravitational influence acting on that matter. So the weight can change, but your mass is what it is. Okay? The only way to change the mass is to physically alter the object. So if you wanted to change your mass, you would either have to eat a bunch of cheeseburgers or chop your arms off. Because if you didn't have arms anymore, then there's less of you and you have less mass. Changing your weight, you could just go to the moon, still be yourself, and be totally fine. Okay? And you'd have less weight on the moon because of less gravity. Generally speaking, a quick, easy conversion is saying that for every 100 grams, or 0.1 kilograms, that's about 1 Newton, which is a capital N for its unit. It's 1 Newton worth of force or weight, okay? Which means about 1 kilogram is around 10 newtons. And this is a very, very, very useful unit conversion to kind of know. Technically, on Earth, it's not exactly 1 kilogram is 10 newtons. It's actually about 9.81, but that's due to gravity, and we'll talk gravity a little bit later. But if you're just doing some quick calculations, 1 kilogram is about 10 newtons, which means 0.1 kilogram, or 100 grams, is 1 newton, okay? So if we just wanted to convert masses to weights, we could do it with these two unit conversions. So if we had a 54 kilogram girl, and we wanted to see what her weight was in newtons, in a force unit, well, 54 kilograms, there's 10 newtons a kilogram. So we just take 54 and we just multiply it by 10, which is really just adding a 0. Okay, so this girl is going to be 540 newtons. If I wanted to train track that, just to kind of show you, she would be 54 kilograms, and then there's 10 newtons in 1 kilogram. And the kilos go away, and we're left with newtons. 54 times 10 is 540. For the volleyball is 270 grams. Well, for every 100 grams, I have a newton. So the 200 is going to give me 2, and the 70 is going to give me 0.7. So this is going to be like 2.7 newtons. And if I wanted to work that out, I could say 270 grams, train track it, and then I could say that every 100 grams, there's 1 newton. If I divide 270 by 100, there's 2 zeros here. The grams are going to go away. And since those 2 zeros are in the denominator, they're going to move the decimal to the left. So I get 2.7 times 1, which is that 2.7 newtons. Okay? So this is just a quick little back and forth between mass and weight. They are different things. They are very closely related. But this is a very, very useful thing for us to know, just kind of going throughout the year. Okay? So a kilogram is about 10 newtons. 100 grams or 0.1 kilogram is 1 newton then. Okay? We'll see how this changes slightly when we have better values for gravity later on, but for right now, and even for later in the year, this is a great thing to just know and be aware of. But for right now, we're finished with that. Take it easy. Have a good one.